And here we are with another lecture. Let's get started talking about simple interest. So, as is given in the title of it, it's actually a way of calculating interest that is simpler than compound interest. And this really happens just in certain types of loans. But as opposed to compound interest, sometimes happens in other types of loans or things like that, or investments for that matter. As we've talked about, loans and investments kind of have the same math that goes along with them, but obviously if you're taking a loan, like, you don't want a high interest rate. If you're doing an investment and you're putting money in and getting money back out, you do want a high interest rate. So let's go ahead and get into what simple interest actually is. And so as I've said, simple interest it's the same type of thing as compound interest, where I put money in the bank, or I take out a loan, and interest will gather based upon how much money I've either borrowed or invested. But the way that that money gathers is a lot simpler in this case than it is with compound interest. And in this case of simple interest, if you put in P as a starting amount, so same letters that we used in compound interest. So P is our starting amount. Let's actually give myself some more space here. So P is our starting amount, and then we have R is our interest rate, just like before. And then T is time, just like before. Then the amount of interest that we get is the principal multiplied by the interest rate multiplied by the time. And that's how we calculate the interest that'll be added into the account. So let's say that that we take out a loan for $3,600. So we're borrowing $3,600, and we're going to do that for 3 years at a rate of 8% per year. And we want to calculate that simple interest. Well, we can just use our formula, I equals PRT, and we can plug right in 3,600. I'll go ahead and put some $ units on that. Sometimes I like to do that, sometimes I don't. Here I will. And then the time is 3 right there. And when we do this, we get $864. And so what that's saying is that because this is a loan, we borrowed $3,600, but at the end of this loan, after 3 years, we're going to have to pay back not only that $3,600, but an extra 864. That's the interest that has accrued over this 3 years. So I have to pay back more. I got to pay back 3,600, and I have to pay back 864. You could sort of flip the script here, and you could say, well, let's pretend this was an investment instead of a loan. So you were putting this into like a bank account or something like that. If you were to put $3,600 into the bank account, and the bank gives you 8% interest per year for 3 years, they're going to add this $864 into your account. And so you'll have more than $3,600. So the reason I'm explaining that is because really what's important here is to calculate what's the final amount that we're dealing with here. If it's a loan, what's the final amount that I have to pay back? If it's an investment, what's the final amount that I have? And so what you could probably come up with on your own is basically what I said before. Hey, if this is a loan, I borrowed this, so I got to pay that back for sure. But then this is the interest that accrues, so I have to pay that back as well. So if I add these together, that's going to give me that final amount that I actually have to pay back. And we can go ahead and do that right here. Let's go ahead and do 3,600 plus 864. Put some $ here. And if we actually calculate this, we are going to get 4,464. And what you'll notice here, what I'm doing is I am actually calculating the final amount, which we've always used A to denote that. And I am adding the principal, which is the amount that I start with, and I'm adding the interest I right there. And so this is a formula that that I really actually don't like saying the word formula, because this really is just intuitive. The final amount that I have to pay back if it's a loan, or the final amount that I have if it's an investment, is just however much I started with versus, and then add to that the interest that accrued on it. And so A equals P plus I, yes, while it is sort of a formula that you can memorize and you can write down on a formula sheet or something like that, it's really just intuitive that how much I started with, add the interest in, that's how much my final amount is. And so we call this the future value. We've used that term loosely before to describe A, just A being, hey, how much do I end up with at the end? We call it future value because it's the amount of money that we're talking about in the future at the end of this loan or an investment. So let's do another example here. It's going to basically be the same thing that we just did. We're going to find the future value of an investment of $2,500 for 6 months at a rate of 6% per year. And so we can go ahead and plug everything in. What we're going to do is we're going to calculate the interest first, and then we're just going to add that interest to the principal, just to how much I started with. So you'll notice here is P, and then here in the blue is time, T, and then here in the orange is the interest rate, R. And we want to find the future value, A. Let's do another color there. A right there. So let's go ahead and calculate the interest that is accrued first. The interest I is going to be PRT, which is going to end up looking like this. P will be 2,500. Again, let's put some units on this, $. R is going to be 6%, which I could write as 0.06 instead. Let's do that. And then here's where we want to be careful, the time. And this is something I haven't mentioned yet, but I'll mention it now that we're doing this example. This time has to be in years. And the reason that it has to be in years is because this interest rate is almost always given in terms of like an interest rate per year. And so in general, our time is going to be in units of years. And so I do not want to put a 6 there. That's bad because that's 6 months. So what I actually want to do is I want to say to myself, hey, 6 months is half of a year. And so I would put 1/2 in for my time right there. Now, let me be clear. If I gave you an interest rate here that was not per year, that would change what the units of this needed to be. So if I gave you an interest rate that's per month, for example, on a credit card, most credit cards will state their interest rate as something like 2% per month. This time needs to be in months. It needs basically the units of this time need to match the units of the interest rate. The reason that I sort of harp on the fact that this is almost always per year is that the interest rate is almost always per year. Just in real life, we almost always see interest rates per year. So most of the time we'll have yearly units. In some scenarios, like with credit cards, which we'll talk about later, we will actually see different units there. But for now, just be careful that you want this time to be in years. So because it's 6 months, I would put 1/2. If I gave you something, I don't know, like if I said it was 27 days for the length of time, you would want to say that in terms of years was 27 over 365, because that's 27 days out of 365 days in a year. That's the amount of years that we would be talking about, 27 over 365. But we'll get into more examples of that later. So we've almost calculated our interest here. If we actually multiply this all out, we get $75, and so that's our interest. So then to wrap things up, we can calculate the future value, which is just A equals P plus I. It's just how much I started with plus how much extra I have because of interest. So I would take my 2,500 I would add 75, and I would end up with a nice $2,575. And so what this is telling us here is that if you actually just go to a bank and you say, hey, you're going to give me 6% per year, great, I'm going to just put in $2,500. Doing absolutely nothing will get you an extra $75 just for, you don't have to do any work. You just have to put the money in their account. Boom. Obviously, it might be tough to just actually, maybe you don't have the $2,500 to start with. But if you do, put it in the bank, hey, you get $75 just for doing absolutely nothing. And that being said, that's just with simple interest here. Simple interest does not accrue as much interest as compound interest does. It's not as good as compound interest. But like I've said, there are certain cases that use simple interest and certain that use compound interest. So now that we know both of these, that's good. We can be on our way. We can talk about, compound and simple interest sort of separately and in different scenarios. Let's go ahead and do another example here. And I'm going to make it slightly more complicated. And what we're going to do is I'm going to give us the same type of problem that we just did here, but I'm going to ask us not what the future value is, but I'm going to ask us what is the monthly payment amount. And again, we can come up with a formula for this, but I like to think about this just intuitively because I personally don't like memorizing formulas. I like thinking about things intuitively and making sure that they make sense in my head. So I'll state here the monthly payment amount of let's say loan, just because generally you're paying on a loan. So the monthly payment amount of a loan, it's the future value. So it's how much you have to pay back when it's all said and done. And then you just divide that by the number of months that the loan was taken out for. So we saw here that our future value was $2,575. And obviously we were talking about an investment, but let's presume this was a loan. You borrow $2,500 and they say, great, thanks for borrowing $2,500. But because of that, you took 6 months to pay us back. We're going to add some interest, and that interest is $75. Right there. So then they say, hey, you got to pay all of this back. Well, that's how much you have to pay back. And presumably you're going to pay this back monthly. And you took out the loan for 6 months. So you have to pay back this amount over 6 months. So all we do is we just take that future value, which we can call A, and we can divide it by the number of months, which I'm going to call N. Right there. We may use different letters for a number of months later, but for now I'll just use N. And so we just end up having this formula that let's go ahead and call this monthly payment amount. I'm going to call this R for now. And again, we might use different notation for that, but R is just A over N. It's just how much money you borrowed and have to pay back, divided by the number of months that you took out for that loan. And there we go. So with all this being said, let me sort of change the narrative here and talk about if this were an investment. Nothing changes here mathematically. It's just the wording changes. If I have an investment, so I put some money in and I accrue interest on that. So, I put $2,500 in, I accrue $75 of interest. This is how much I have at the end of all of it. If we were talking about this in the sense of an investment, this would be talking about how much money you would sort of be getting on a monthly basis. You'd be getting that amount this amount divided by our 6 months on a monthly basis. Generally, this monthly payment amount isn't talked about with investments. It's more so with loans because you're actually paying someone back, but that's fine. We can talk about it in terms of investment. So let's go ahead and do an example here. And so Jake borrows $4,500 at 8.5%. We'll notice that I don't put 8.5% per year. If I do that, if I just write the interest rate here, you can assume that it is yearly. So we can sort of assume, let's go ahead and put this 8.5% per year. Sneak that in there. You can assume that because I don't state it. And then what I'm telling you here is that he has to pay $2,756.25. So I'm actually being nice here, and I'm not bothering to tell us the actual the actual, like, we don't have to calculate the interest is really what I'm getting at. I just give it to you. But where I'm sort of mean is that I don't have the time in here. And if we're going to find monthly payment, we got to know how many months that we're dealing with here. We got to know how long this loan was taken out. And so let's go ahead and just mark everything up that we know. So 4,500, that's going to be the P, that's the principal amount that was borrowed. We're also going to have 8.5%, which I'll label as R. We're also going to have this 2,700, which I'll label as the interest I. And what we want to do is we want to find the term of the loan, and that's just going to be the time, T. And we want to find the monthly payment, which I'm going to indicate with R. So monthly payment, I'll call this a capital R. Don't get confused between capital R and lowercase r. They're obviously very different things, monthly payment and interest rate, respectively. So let's go ahead and start off. Let's do I is equal to PRT. And the reason that I'm using this formula is because it has a T in it. And that's what we're trying to find. We're trying to find the term of the loan. We're trying to find how long this loan went on for. And I actually have the interest rate I, the principal P, and oh, excuse me, I said interest rate I. I mean, we have the interest I, the principal P, and the interest rate, lowercase r. And so I can just go ahead and do this here. If I plug everything in, my interest is 2756.25. My principal is 4,500. My interest rate is 0.085. That's the 8.5%, but put in a decimal format. And my time is T. And so all I have to do here is I just have to divide both sides by 4,500 and 0.085. We'll show that right there. 4,500 and 0.085. Divide by 4,500 and 0.085. And we end up with a nice T is equal to 7. And I'll make the note that it's 7 years here. So there we go. We've got T is equal to 7 years. I'm going to make one more note as well. And that's that 7 years is equal to 84 months. So I'm just taking that 7 years and multiplying it by 12 months in a year. So 7 years is 84 months. So now let's actually go ahead and let's go ahead and just give ourselves a new page here. We can actually now calculate the total amount that had to be paid back. And once we have that, we're basically done, because once we have the total amount that has to be paid back, we can divide that by the number of months that we found right here, and that's going to be our monthly payment. So total amount that I have to pay back is A. I'm going to say, hey, well, we borrowed 4,500. The interest was 2756.25. So this ends up being 7,256.25. That's the total amount that was paid. And so now I just take that amount. I'll say that R, my monthly, capital R, my monthly payment, it's just the total amount that I have to pay back. And I divide that, by the number of months, not the number of years, because we're talking about a monthly payment here. If I was talking about number of years, you'd want a yearly payment, you'd want to divide it by 7. Maybe I would even talk about a weekly payment, and you'd want to divide it by however many weeks are in 7 years. But here it's a monthly payment, so we want to divide it by the number of months. And when you do that, you get a nice $86.38. I'm rounding that to 2 decimal places because we're talking about money here, and we definitely want to go to the nearest cent. So that's our monthly payment right there. We've calculated it. We also know the term of the loan is 7 years or 84 months. We've answered our question. That's great. Let me go back through all of this, just showing it again and sort of explaining it one more time, just because I know that that problem can seem a bit roundabout. So we're given all of this info in the beginning. We're given how much we start with, how much we borrow. We're given the interest rate, and we're given the amount of interest. So really, I use that information right here to find the time. And then I use that same information to find the total amount paid. You can see that right there, all boxed in the red. Once I have the total amount that's been paid and the amount of time, I can just divide them to get my monthly payment, because however much that the amount that I have to pay at the very end, if I just divide that by the number of months over which I have to pay that, that gives me a monthly payment. And that way I don't have to just pay 7,200, in one lump sum at the end. I can do monthly payments of just $86, and that'll get me there. So yeah, there we go. That's simple interest right there. Really, the big takeaways here are these two big formulas here. I is PRT, that's the way to calculate simple interest. And then the future value, the total amount that you'd borrow or invest or have at the end, right? We'll call that future value. That's just how much you start with, and plus the interest that accrues. And obviously this right here, this formula goes for anything. This formula goes for compound interest. It goes for simple interest. It goes for other things that we have yet to talk about. This is just a general sort of like form. It's not even really a formula. It's just like a general common sense sort of idea that how much you start with, add the interest to that. That's how much you have to pay in the end. So we'll go ahead and leave that there for the lecture, and that'll be good. That'll be it.